everyone, I'm Domingos and I'm also known as DMA, and I really appreciate when I'm called DMA. So today we're going to continue on the quadratic function that we started, but more specifically today we're going to be finding the roots of the quadratic function. Okay, so first of all, let's start. What is a root? What do you think a root is? Maybe you go to a tree and then try to find the root of that tree? Of course not. In mathematics, a root is finding the independent variable value when the dependent variable is equal to 0. But today we're going to start for incomplete quadratic function when b is 0 and the c is not 0. For us to know that this function is incomplete, let us remember that the complete form is y equal to ax squared plus bx plus c. That's the complete form. So let's start by solving the incomplete form. B is missing, that means B is 0, and C is not 0. So that's the quadratic function. I don't need to mention A because we say A can never be 0, otherwise it's no longer a quadratic function. So finding the roots of this quadratic function, in another word, they saying is finding x when y is 0. So finding a root of an equation is finding x when y is 0. So when y is 0, we find x. The method for us to solve finding x is factorizing method. Factorizing method is transforming a sum into a product, or we can apply another method that we feel comfortable, that we may feel like applying to solve the equation. Okay. So let's give example. Let's say we have y equal to x squared minus 9. If we look at this function is a quadratic function because there is x squared. But there is no b, a term that multiplies the x. That means our b is 0. And finding the root is actually saying that y is 0. And when we say y is 0, we have x squared minus 9 equal to 0. So this is an equation. This is an equation. But it's not just an equation. This is a quadratic equation. I'm going to put equation in second degree. That means that's a quadratic equation. So how do we solve this quadratic equation? Since this is incomplete, we have to transform this sum into product. There is no common factor. There is x here, there is 9 here, so there is no common factor. By looking, we can't factorize. So we have to remember the binomial rules that say x squared minus b squared is equal to a minus b times a plus b. That's the difference of 2 squared. So we can transform this equation into difference of 2 squared by saying that x squared minus, we can write 9 to the base of something to the power 2 for us to be able to fulfill or to apply this rule. So 9 is 3 squared equal to 0. Now we're going to have, applying this, we know that it's going to be x minus 3 multiplying x plus 3 equal to 0. Now a product of two expressions is 0. When is that the product of two expressions will be equal to 0? When? If at least one of them is 0, of course. Because if they are both positive, the product will never be 0. If they are both negative, the product will never be 0. So if at least one of them is 0, the product will be 0. So we say then x minus 3 equal to 0, or the other one equal to 0. Because why we're using or and not and? Because we don't need for both of them to be 0 for the product to be 0. If at least one of them is 0, this product will be 0. That's why we use condition or and not and. So solving here, isolating x will be equal negative 3, sending that side, change its sign, goes positive. Or, in another word, we are adding 3 both sides. So that means x will be 3, or x will be, here we will subtract 3 in both sides. So subtracting 3 will only be x, 0 minus 3 will be minus 3. So the solution for this for this problem is x equal to 3 and x equal to minus 3. So if they tell you find the roots of this function, in other words, they're saying find the independent variable value when the dependent variable is equal to 0. That's what we stated here. So those are the values of x. Okay, now let's solve this incomplete equation. It is equation because y was already made to be 0, and we are required to find the roots of this function, of this equation. It's the same thing. So what do we do first? We can divide both sides by 2, just to make x squared to be 1. Why? Because makes that easier. So dividing all the expression by 2, 2 divided by 2 is going to be 1, so x squared plus 8 divided by 2, it's going to be 4, and 0 divided by 2, it's always 0. Now my question is here. There is no way for us to apply this rule. There is no way for us to apply the difference of 2 squared in real numbers. There is no way. Even if we add both sides by minus 4, we will have, if I add both sides by minus 4, let's say I add, which is subtracting, I will have x squared plus 4 minus 4 equal to 0 minus 4. And here they cancel out. I will have x squared equal to minus 4. When I isolate x, which I say it is implied putting square root in both sides, and that will be x equal to plus or minus square root of minus 4. Because when I put the square root here, 2 and 2 cancel, so x will be plus or minus square root of minus 4. Now, when we are required to calculate the square root of a negative number, if the index here is even, it is impossible in real numbers. So there is no solution. So there is no any real number that satisfies this equation. So that means this function does not have any real roots. So this is how we would approach this problem. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.